What is good, guys? Today we're going to be talking about SCC, stress cracking corrosion. It is the most violent form of corrosion because two things are happening simultaneously. The first thing is normal, like stress. Okay, you got the steel beam, right? We usually talk about pipe, but let's think about beam. It's getting pulled. That's a tensile stress, so it's under tension. The second thing is corrosion, right? This whole channel is about corrosion. So when you put metal in a salty environment, it'll get eaten away and corroded. So when they're both happening at the same time, it'll fail so fast and so dangerously because usually it'll be like 10,000 psi for the pressure to make it burst or like fracture. And when they're both happening at the same time, SCC, it'll fracture in 600 psi. So just way quicker, way quicker. 6% rather than 100%. So to explain it in simple terms, think of uniform corrosion, like the regular corrosion we think about, as a surface on the car, right? You kind of see it slowly forming, right? You start seeing the orange, and then the whole thing starts getting painted in orange, right? So a rash on the skin. That's how I think of the analogy, rash on the skin. This is like a heart attack, okay? It gets tiny microscopic cracks that tunnel deep inside, um, while the outside looks regular, right? So when someone has a heart attack, you don't really see it coming, they just fall. So that's what SCC is. Second thing is it's brittle, okay? So usually when metals fail, it's ductile. Ductile means it'll stretch or bend before it breaks, right? You can see it kind of like breaking. Brittle means it'll happen that fast, right? Like glass. Glass is brittle, or a twig is brittle. When you snap a twig in half, it snaps. That's the right word to use. It snaps. And the third thing, so it doesn't bulge or bend before it collapses. The third thing is the branching effect. So these cracks don't go straight. It'll kind of branch like a lightning bolt. They'll follow like the seams between the microscopic grains of the metal, making the structure crumble from within. Okay, so now we pretty much completed the video, but let me explain like the pairs with the metal and the kryptonite environment. Kryptonite is like Superman's weakness. Like, what's the worst environment for that metal? Okay, so first of all, stainless steel. Stainless steel is our strongest steel, but the kryptonite is chloride because well, we'll worry about that in a different video. But real world examples where you could see it in is pool equipment, coastal bridges, or industrial boilers. Okay, so I'll say the metal, the kryptonite, and then where you'll find it. Another thing would be brass and copper. The kryptonite would be ammonia, and that would be in antique bullet casings or old plumbing near cleaning supplies. Third thing is carbon steel. Carbon steel, the kryptonite would be lye or nitrates. That could be in fertilizing tanks or high pressure steam pipes. Fourth thing could be high strength steel. The kryptonite is hydrogen sulfide. That could be in oil and gas pipelines, also known as sour gas. Fifth is aluminum alloys. Kryptonite is seawater or moist air, so don't have any aluminum parts in any marine things you're trying to build. So that would be in aircrafts or marine structures. Last but not least, titanium. It would be in methanol or hot salt. That would be in specialized aerospace or chemical processing parts. So in those more technological stuff. So I always try to relate what we're learning back into like real world examples. So just to, I don't know, increase the length of the video, but thank you for watching SCC. I'll see you guys in the next one.